Today we are dealing with Bose integrals. So we have these two integrals, and these two are awesome integrals since the first one is the product of gamma and zeta function. The second one is the product of gamma and Dirichlet eta function. Yeah. Okay, so let's begin with the first one. We have this integral from 0 to infinity x to the power p minus 1 by e to the power x minus 1 dx. First of all, we can make this as a geometric series so that we can express it as an infinite sum and then exchange integral and sum and then really simplify the expression. So this can be written as e to the power minus x by 1 minus e to the power minus x. So if we change it to this form, if we just multiply numerator by e to the power minus x, this goes into the form of a by 1 minus r. So, and since r is less than 1, this can be written as an infinite sum. Okay. And we have sum going from I equals to 1 to infinity e to the power minus x to the power I and then dx. Okay, so this is this geometric sum. First term is e to the power minus x and the rest is also e to the power minus x. And now we can just take this expression inside the sum, since the sum is in I and this is in x, doesn't matter. And also we can extend the sum in integral since it's converging. So we have sum from I equals to 1 to infinity, integral from 0 to infinity, x to the power p minus 1 e to the power minus ix dx. So now this is just through the Laplace transform, or through just gamma functions, we can easily solve this one. So the result for this will be gamma p by I to the power p. And now to sum this one, gamma p is just constant, we can take it out, and we will have sum from I equals 1 infinity of 1 by I to the power p, which is just zeta function of p, and this solves the integral. And for the next one, so we have basically solved the first integral, and for the next one it's kind of similar but not exactly same though. We have integral from 0 to infinity, so x to the power p minus 1. We will first make the same manipulation, e to the power minus x by 1 plus e to the power minus x, okay, dx. And now we'll bring it to the formula of symmetric series, a by 1 minus r, so that gives us e to the power minus x by 1 minus e to the power minus x dx. With that we have, now since r is less than 1, we can take it to geometric series. The sum from I equals to 1 to infinity. Here the first term is e to the power minus x, okay, so e to the power minus x, and here minus to the power I, but to make the first term positive, first term is just e to the power minus x, we can add here minus 1, that will be a good thing to do. So we have this expression minus 1 times, or let's say we can also do it like this, we can also send it to e to the power minus x to the power I and then minus 1 to the power I plus, let's be next to the row, I plus 1, okay, this one is also fine, and this also like captures this symmetric series, and then dx. Now we can bring this in, and we get summation from I equals to 1 to infinity, and then integral from, you can take this out of course since it's nowhere related to world of x, and the integral from 0 to infinity x to the power p minus 1 e to the power minus ix. So we have the similar expression again, and we have sum from I equals to 1 to infinity, and we have minus 1 to the power I plus 1, and this one is again from Laplace transform or from the gamma function. This can be written as gamma of p by I to the power p. Is it here? I to the power p. Yeah, okay, now fine. And then now we know that this is actually, if we take gamma of p out, this actually becomes the Dirichlet function. Integral summation from I equals 1 to infinity minus 1 to the power I plus 1 by I to the power p. If you just want to see how it looks like, so this looks like 1 by 1 to the power p, yeah, and then minus 1 by 2 to the power p plus 1 by 3 to the power p minus 1 by 4 to the power p, and so on. So this is actually the Dirichlet function. So this gives us gamma of p Dirichlet function of p. So this proves the result. Note that these are just some convergent geometric series and the exchange of integral and sum formula, and that was it. I hope you enjoyed the solutions, and these are some of the really beautiful results in maths, and it's really fun to play with them. Hope you enjoyed this video. Thanks for watching. Look forward to seeing you in the next video. Do like, share, subscribe.